Good morning, everybody. Let's test it once again. Are you able to hear my voice and see the video now? You can use the chat window to type them and tell me if you're able to hear my voice and see the video. Okay, so good morning, everybody. Once again, my name is Piotr, and I'm gonna do a quick view lecture about the device sensor feature, which is a technology that we can use on the network access devices in order to enhance the profiling feature of the identity services engine. So profiling is basically a function or just a technology that we can use to detect, classify, and localize the connecting endpoints with the device sensor feature. This one is actually an enhancement down on the NASs, on the network access devices, I should say, that allows us to gather some more attributes about the connecting endpoints than just the IP address or MAC address of the device. So we're going to take a look at both the wired configuration for the device sensor feature, which is going to be done on the Catalyst 3750 switches. And then we will also take a look at the wireless configuration on the WLC. Okay, so let's take a look at the topology here. So as I mentioned, we're gonna start with the wired configuration, and we will be using a single switch and a single identity services engine that is configured as a standalone device, meaning that it is going to be also acting as a policy service node. So we're going to have a single VLAN with ISE. Then the switch, this is going to be cat-free SVI for this VLAN. This is going to be the 10.1.1.1.0/24 subnet. Now we will also have a WLC management interface in the same VLAN. This is going to be 250 for WLC, 130 for the switch, and ISE is gonna be using 10.1.1.150. This is what I'm going to need here for the wired part. We will also have somewhere down the network. It doesn't really matter. In this case, it's not really important to know what's between those segments because we will not be testing connectivity at any point. We will also have the 19.2.5/24. And this is going to be this is VLAN 25, which I will be using to test the wireless device sensor. The clients are going to be associating with a certain SSID we will then configure, and they're supposed to be placed into this VLAN, and router 4 in this case is going to be acting as a DHCP server. So this guy is going to be using 19.2.5.4, but as I said, we're going to take a look at this later when we finally get to the wireless part. So let's now focus on the wired connection here. So Catalyst 3, we will have a single IP phone connecting to this device, and this is going to be a gig 1012 on this switch. And what I will be trying to do here is that I will be configuring this interface for a MAC authentication bypass. So we will basically enable .1x on this device. We will configure .1x accounting because the device sensor collected information is going to be actually encapsulated into the radius accounting packets, and those accounting packets we will then send to the identity services engine so it can process those attributes and evaluate them against the profiling policy rules. So let's take a look at the command line on the switch. So I definitely want to enable AAA framework, because we will have to define two different method lists. One is going to be for authentication with .1x, and the other one is going to be for accounting. So AAA authentication and .1x, the method list name must be default, and we will be using radius for .1x authentication. Then for accounting, also for .1x, the same method list and radius. Okay, so then I'm gonna define our radius server, which is gonna be ISE. So as I said, this is actually 10.1.1.150 radius server. I'm gonna call it ISE. This is by the way, the new syntax of configuring the radius or TACX servers on the switches. Radius space server, then you give it a name, and you have an option to specify the key, the IP address, and some timeout and retransmission options. So the key is going to be IPexpert, the IP address, and by the way, this syntax also allows you to configure IPv6 address of the AAA server. In our case, this is going to be IPv4 10.1.1.50. So we've got if we take a look at this configuration, we've got just two method lists defined for authentication and accounting. We have defined our radius server, our identity services engine. Now, I'm gonna now enable .1x framework globally, and we will enable let's say that at this point, we will basically enable the MAC authentication bypass on the port. So I'm not gonna enable I will not be sending the VSA, the accounting package to the identity services engine. The accounting information for the device sensor is not gonna be sent because I'm not gonna enable the device sensor feature at this point. What I just wanna show you first is gonna be what kind of attributes we will get with just the authentication for .1x being enabled. So switch is going to be sending access request packets to the identity services engine. It is going to tell ISE about the MAC address of the connecting endpoint for the calling station ID attribute, and we will basically take a look at the other attributes that were learned for this endpoint when it's detected by ISE. So I just want to show you the difference, what we will see before the device sensor feature is enabled, and what is going to be the change once the feature is enabled. So .1x system authentication control, and now the port configuration. Gig 1012, this is where we have our IP phone connected. I'm going to shut it down initially. This is going to be an access port. The voice VLAN is going to be this one, 800. Now we will say that for authentication, we want to use MAC authentication bypass, and just this method. Then we want to enable .1x on this interface. And this interface is supposed to act as an authenticator in the .1x process. And I want to enable MAC authentication bypass. Let's take a look at the commands here. So we've got an access port, the voice VLAN is defined, MAB is enabled, the first method that is going to be tried to authenticate the device is going to be map, and we have enabled that on X. Okay, so now I need to go to the Identity Services engine and add get free to the network access devices as one of the clients, and we will also have to enable the radius probe. So let me log into the ISE here. So once again, the expectation now is that when I bring the interface up, what we should see here is that this is going to trigger a radius access request packet sent to the ISE, and one of the attributes being included in this message is going to be the calling station ID, which is going to be the MAC address of the connecting device, so of the phone. And we should see this information is going to get populated in the endpoint database. So let's go under Administration and Network Devices. And so once again, the first thing I need to do here is going to be to add our switch. So I'm going to click on Add, give it a name, specify an IP address, and obviously the key must match what I have configured on the NAD. It was IPexpert for the key. So get free, this is 10.1.1.130 based on our topology here. So SVI for VLAN 100 is going to be using this IP address. Now then the key, so authentication settings, and IPexpert. So just this information, we have added the client, and now I need to enable the radius probe. So go back under Administration, and then under System and Deployment, I'm going to select our standalone ISE. And under the Profiling tab, this is where we will be able to activate the different profiling probes. So in our case, we need just one. We just need to enable the radius probe because we want to process the attributes received for the radius package. Once this probe is enabled, now let's now quickly go back to the switch here, and let me make sure that we actually have an SVI defined for the communication. So we have the SVI defined. We have previously defined our ISE. I am able to reach Identity Services engine. Now let's see if the communication is going to be actually working here. So I want to test our radius communication between the NAD, between the switch and the Identity Services engine. Test AAA group radius. Some random credentials. They don't have to match what you configured on ISE. If they don't match, which is our case, you're going to see the reject message. But this means that the devices can actually talk to each other using radius. So now at this point I know that that my switch can actually talk to the Identity Services engine using the radius. And we can go back to the interface here. Now maybe before I bring the port up, let's also enable a debug for radius accounting package. So interface gig 1012, let's say no shot, and let's see what's going to happen here. So it says that it started the MAC authentication bypass and the authorization failed. Well, obviously the authorization failed in this case because we don't know that the ISE doesn't have any information about this endpoint in its database. But at some point here, it should finally populate this information from the radius packet. It should send a message with the calling station ID attribute. And so let's take a look at the endpoint database. It says that it learned about one of the VM devices, but I don't believe this is going to be the phone here. So at some point it finally got some traffic from the phone, and it starts sending the accounting packets for .1x. So when the session started, and what was the amount of traffic exchanged, and it also included actually this is the called station ID. The calling station ID is this one here. So this is for C1, C6, which I don't believe is a phone. Let's say do show CDP neighbor for this interface here. Let's take a look at the detail output. And let's also, maybe let's just take a look at the content of the count table for this interface. So I have two devices here. One it says is in the voice VLAN, and one is in the data VLAN. Well, actually, I think that one setting I didn't enable on this interface here, which is the authentication host mode. I will not change it to multiple authentication. At this point, I have two devices connected to this interface. One is going to be the phone, the other one is the PC. I don't believe that my authorization policy is configured, meaning that when the phone authenticates, it will not be placed into the voice VLAN. So basically, it's like you have two devices that try to authenticate to the data VLAN, and with the default setting for a host mode, which is single host, at some point we should basically see that a violation would occur. So I wanted to change the mode to be multiple authentication, which allows for multiple devices in the data VLAN and a single device in the voice VLAN. Now we will now bounce the port. So it sends another radius accounting packet. I only saw C6, which is the PC. Okay, so I brought the port up, and let's now go back to the Identity Services engine, and let's refresh the database here. So now we see that at some point it finally sent information about the connecting phone using that calling station ID attribute. And so this device was profiled since the radius probe was enabled on ISE. And this device got profiled and is now showing up as Cisco device. So when we take a look at the attributes of this phone, at this point we actually don't know that what type of device it is. I know it is the phone because I know that there are only two devices connected to this port. One is the VM test PC, the other one must be the phone. But based on this information, it doesn't actually give us a clue on what type of device it is. We only figured out that the device was manufactured by Cisco, and this was learned from this information was learned from the MAC address from the first half of MAC, which is basically the organizational unit identifier, so the vendor. And this is why the device got profiled as a Cisco device. And we see that the source of the probe information is radius. So this is what happens when the device sensor feature is not enabled. We did not enable any other types of probes such as SNMP, DHCP, HTTP. We have only the radius probe that's the one that's enabled. So now what we will do is that we will extend this radius functionality by enabling the device sensor feature, and we will see what is going to change here when those additional attributes will be sent to ISE. So let me undebug all for a second. Once again, this is the configuration we have now for AAA, .1x authentication and accounting for .1x. Now, two additional things we will have to do here. One is going to be to enable the feature using the device sensor command, and we want to send the device sensor information inside of the accounting package. And then we also want to send the information whenever the TLV was added, removed, or modified for the endpoint. So no matter what type of attribute was detected, whenever something changes, we want to send this information to ISE. At this point, we should see that we should have an entry for gig 1012 in the device sensor table. If I say show device sensor cache all and look for our interface, we see that there is an entry here for the IP phone, and this information is learned from the CDP packets. So on the switches, there are actually three protocols you can use for the device sensor. This is going to be CDP, LLDP, and DHCP. If I wanted to use DHCP, I would also have to enable DHCP snooping on the switch for this VLAN. Now, in our case, we see that the information we will be able to get for CDP, this is going to be the platform type, the host name, and capabilities, and a couple of other different elements. So ideally, we should see this that when I finally enable the feature, this information is going to be sent inside of the radius accounting package to ISE, so it can use those attributes and match them against the profiling policy rules. So one additional element I need to define here, I need to configure on the switch, is going to be to tell it that it is supposed to start sending. Now this is going to be radius server VSA sent for accounting. So I want to start sending vendor specific attributes in the accounting package, and those device sensor collected attributes, they will be actually sent using Cisco AV per. So let's debug radius for accounting, and let's bounce the port and see what information is now going to be sent to ISE. So this is just the information, the accounting packets, the regular accounting packets, what it is sending now to tell ISE that the .1x session was terminated, and the statistics, the amount of traffic sent, received by the device. Now we will say no shot, and in some other accounting message, we should see those this device sensor information being included. So this is going to be actually this packet here. It says that the calling station ID is our phone, and it sends the information which was learned via the CDP. So let's undebug all and let's go back to ISE. And if I now refresh the output here, we see that the profile has changed for the device. It is now showing as an IP phone as 7960. So I'm gonna take a look at the details for the attributes of this device. Scroll down a little bit here. It says that the endpoint that matched was Cisco device. This is the policy selected for this device, and the source of the information, source of the attributes, was the radius probe. So in this case, these were the radius accounting packets. We had a match in this profiling rule, and the attributes gathered for the radius probe. This is the CDP related information. So the device ID, the host name, and then the platform. This information was evaluated against the profiling policy rules, and this is how we had the profile for the device was changed. It's now the group selected for this device is Cisco IP phone versus the profile matched was Cisco IP phone 7960. So this is how this feature works for the wired connections. If we go back to the switch, and just to quickly recap on the configuration here. So let's say section AAA, radius, and device dash sensor. So we have enabled the framework, specified two lists for that one X. One is for authentication, the other one is for accounting. And we have enabled the feature globally on the switch. And we have enabled VSAs for accounting. And we finally defined who's our radius server. One additional thing that is not shown here, I also enabled the .1x framework globally using this command. And this is the interface configuration. So I changed the mode because I know that there's more than one device connecting here in the data VLAN. And we've got the authentication order, which is set to MAB. And we want to use .1x to make a decision on whether the device is authorized or not. And finally, I have enabled MAB and specified that the port is supposed to act as an authenticator in the .1x communication. Now, if you take a look at the documentation for this feature, or make some additional reading, some of the documents are going to tell you that it is not needed to enable authentication, authorization with .1x for this feature to work. But what I found out on this particular platform is that without the .1x authentication enabled and without activating it on the interface, so this is 1502 SE, what we are running here on 3750X. I was actually not able to get those accounting packets to be generated by the switch. But the documentation says maybe this is going to work on some other platforms. I'm not really sure. I wasn't testing this feature on some other devices. I know that on this box, with this configuration, as you saw, the feature is gonna work all the time. Versus maybe on some other devices, it is gonna work with just accounting enabled and nothing else on the interfaces. Okay, now let's move on to the wireless configuration. So I'm gonna take a look at I'm gonna connect to the WLC. HTTPS 10.1.1.250. And the couple of different elements I will need to define here. Well, one is going to be the interface we will need here that I will use later to associate it with our wireless LAN. So the wireless LAN, we're gonna call it Corp 124. This is gonna be SSID, and this SSID is supposed to map to this VLAN. So the clients will be actually, when they associate, they will be put into VLAN 25, and they will be trying to obtain an IP address from our DHCP server, which is router 4. So this is what we are trying to do now. Just configure the wireless LAN. So on the controller, under the interfaces, I'm going to create a new one, which I will call Corp IF. This is going to be VLAN 25. And the physical port is number 1. Then the IP address for the interface, 19.2.5.250/24. Router 4 is going to be our gateway, and router 4, as I mentioned, is also going to be acting as a DHCP server in this network. So 19.2.5.4. Okay, so this is the sub interface. And now let's take a look at the wireless LAN configuration. So let's add a new one. SSID is going to be Corp 124. And then I'm going to select the Corp IF interface. So at this point, we should see that when the traffic gets to the wired network, it is going to be actually it is going to be sent to VLAN 25. I want to enable this sub-interface, and let's also disable any type of authentication and encryption. This is going to be an open authentication network. So let's do this now. And let's go under security. And the one thing that we will have to do here is going to be to add our ISE to the as the radius accounting server. So on WLC, I will not actually have to specify any type of authentication servers. I will not have to authenticate either via map or .1x with just an accounting server added. What we should see is that this information is going to be, the attributes are going to be collected for the endpoint, and they will be sent down to ISE for analysis. Now, one thing that I will actually change here is going to be the MAC delimiter, because I know that ISE uses colons to separate MAC addresses in the endpoint database. So I want to match this. So let's apply, and let's say new. Let's add the ISE as the accounting server. 10.1.1.150 IPexpert. I'm going to leave the default port 1813. Let's just apply. And let's now go back to the wireless LANs. And let's modify the settings here for this LAN. Security, so this is what we need under security. Once again, open authentication, and then I need to select my accounting server, so where I'm going to be sending my accounting packets to this guy here. The database order is fine, and now this is where I actually enable the device sensor for wireless. So I want to mark these two checkboxes. One says a DHCP address assignment is required because the only protocol supported for the device sensor in this WLC release is DHCP. So I definitely want to see the DHCP exchange, and I want to enable the device sensor feature for DHCP. So client profiling, this section here, just one checkbox, and the other one is going to be this one, DHCP address assignment. So when I now apply this, let's also go to the monitor tab and see if our access point was detected. It was. So when I enable the wireless card, well, actually, before I enable the wireless card, there's going to be one more thing that we will have to do on the ISE. So I still have to define the WLC as one of our clients, because this device is supposed to receive and process the radius packets from WLC. So add it as a new client, WLC. This one is 10.1.1.250, and IPexpert was the key I have configured on the controller. So submit. The radius probe is enabled from our previous configuration for the wired connection. So this is going to be the only configuration that I need here on the ISE. Now let's also take a look at the identities and the endpoints. So we should see just two devices, those detected by the wired connection. So a phone and a test PC. Okay, so let's now go to the test PC, which is also where I have my wireless NIC. I'm gonna enable it, and we will try to connect to our SSID core 124. So when I connect, what you should see that happens is that when the device obtains an IP address via DHCP, this information is going to be sent to ISE inside of the radius accounting packet. And the network here is going to be this one, Corp 124. So it says associating and then acquiring an IP address. Now let's take a look at the IP config. So we see that the wireless card, it finally obtained an IP address from the 19.2.5/24 subnet. If we go and take a look at the ISE endpoint database, we should see an entry here added for the wireless card, which we do. So it says this is a Cisco device because this card is actually a Linksys adapter. So now it says that the source of the profiling data was WLC. I learned this information from the radius probe. The IP address assigned to the client was this one. And this is this card was manufactured by Cisco Linksys. And this is the information I have gathered from the DHCP packets themselves. So it says the DHCP option, the host name is this one. This is also the DHCP option is another attribute that we have collected. And this is the host name and the class identifier. So this information here is and up to the IP address. This is something that we have obtained from the DHCP exchange between the client and the server. Do you have any questions to this session? Okay, if there is no questions, I just wanted to say thank you for attending this lecture, and wish you all the best in your preparations.